Hi, I'm Matt Legg, Technical Lead with Syngenta Professional Solutions, and I'm here at the Honeywood Research Facility inside of our Applications Technology Lab with Xin Liu, Application Specialist. We're going to talk a little bit about our art of application today, but before we start, Xin, why don't you tell us a little bit about your role here at Honeywood and what you do to support our products?
Sure. Thanks, Matt. My name is Xin Liu. I'm an application specialist, and my role in Syngenta is performing application testings to ensure our customer have the best experience when using our product.
So Xin, in the field I get the question a lot of times, what is the best nozzle for the job? And I think one thing that's important with our applicators to understand is that there's many components to a spraying system, but nozzles are the last component and maybe the most vital component yet often overlooked. Can you tell us a little bit about how you would go in selecting the right nozzle?
Sure. In selecting nozzles, first we want to know what kind of product we want to apply and where it is intend to be placed.
So I guess we want to think about mode of action. So as a superintendent, I'm thinking maybe contact products on the leaf blade, systemic products on the leaf blade or farther down into the canopy. And maybe if I'm going for a root applied application down to the root system, I really want to make sure that I have enough water volume to get down into the root zone.
Yes, that sounds about right. For the turf, 400 to 800 liter per hectare is a very typical range. And sometimes it can go as low as 250 liter per hectare based on the label. On the other hand, it can sometimes go up above 800 liter per hectare.
So Xin, now that we know the output that we're desired based off of manufacturer's recommendations, where can we really go to figure out what nozzle that means for use in the field?
Good question. Most of the time, manufacturer will produce some nozzle selection guide. And in the guide, most of the time, there is a flow chart we can follow and find our right output range.
So if we're referencing a flow chart, there's obviously going to be many different nozzles that we can pick from. What happens, for instance, if we have two nozzles that might give us the right output that we're looking for, but maybe with different travel speeds or pressure ranges?
First, we always want to make sure we have reasonable travel speed, and we always want to select the nozzle in the middle range of its designed pressure, follow the safe speed we travel.
So again, we're operating at a safe travel speed. We've chosen a nozzle that's in the middle of its ideal pressure range. For me, my head goes to somewhere between 35 to 45 pounds per square inch or PSI. Does that make sense to you?
Yeah, that is the normal range for most of the nozzle designs on the market.
So Xin, I'm curious, what happens when we fall outside that ideal pressure of a nozzle? What are the ramifications?
We can use our table sprayer to demonstrate what you just said. And this is the 04 nozzle. Right now, it's spray under the ideal condition. And you can see it's provide really ideal output and the ideal pattern as well.
So we have a flat fan 04 nozzle here. We're at about 45 PSI. That ideal zone. I'm going to turn things up to maybe 65 PSI, really stretching the limits as to outside of recommended pressure. And let's see what happens.
As you can see, you increase the pressure and you increase your smaller droplets. Smaller droplets always prone to drift.
So I'm assuming that if I hold up a piece of water-sensitive paper, I'm going to start to see those droplets coming off that spray, which is indicative of the drift that we might see.
Exactly.
And what happens if we go the other way? I'm going to turn the nozzle down to maybe 10 PSI, and I want to see what happens when we drop too low.
So it's pretty clear, when you decrease the pressure, you can see the spray angle changed. It's way smaller than it was originally designed.
And that's got to be a big concern, because if we're not getting that right angle of output of the sprayer nozzle, we're not going to get 100% coverage from tip to tip. So our application is going to be way off.
That is correct.
So what we saw under that example is that under ideal pressure with a flat fan nozzle, we get really nice uniform coverage across this water-sensitive paper. But as you can see here on my left, once we drop the pressure outside of that normal zone down to 10 psi, we've lost a lot of the small particles, and as a result, we've also lost a lot of coverage. I'm assuming that's the same case under the high pressure, but in a different example.
Yeah. When we increase the pressure and we create more smaller droplet and smaller droplet prone to drift.
So we talked about output, we've talked about pressure, and now it's really led us down to this discussion about droplet size. I'm assuming that we can choose a nozzle's design to influence the droplet size that we want at an intended pressure.
That is correct.
So Sheen, we've got 3 different nozzle types here that we typically see in a turf setting. Can you maybe explain to me the different nozzle types we've chosen for demonstration?
Sure. This is the flat jet, and in the middle, it's a flat fan nozzle. On your hand, it's an air induction nozzle.
So having worked in the business, I remember the days when I was using a flood jet nozzle for a lot of my applications, but technology has really advanced. And what I generally find now is that we're using that type of a nozzle for root applications because it's making such a large droplet size.
That is right.
I kind of think that we move next into that flat fan nozzle. We talked about how uniform of an application that a flat fan nozzle can provide, which is great for, say, contact products. But the downside that we've always seen in the field is that drift is always a concern. So what I've seen is that we've now moved to air induction technology. Air induction technology is kind of the best of both. We get less drift, but we still retain those kind of coverage qualities that we had in a flat fan nozzle. Why don't we put the nozzles on the output hood here, and we'll kind of see what we produce with the water-sensitive paper. So we've installed our nozzles in the range hood. We have them operating at really an ideal pressure around 45 pounds per square inch. And we have our flood jet, our flat fan, and our air induction. We talked about the importance of output, the importance of pressure, and now we're really talking about the importance of droplet size. Can you explain to me the differences we might see amongst these designs when we talk about that droplet size characteristic?
Sure. Let's take a close look at the test that we did on our water-sensitive paper. So this one is from Flat Jet. You can see it is provide larger droplet, but smaller coverage. And this is from our flat fan. It does provide a lot of smaller droplet size and very good coverage. And this is from air induction. It's in the middle range. Both provide larger droplet size, at the same time provide better coverage.
So when I think to an applicator in the field in a turf setting, I can kind of summarize it by saying flood jet's probably when we want to put products down into the root zone. Our flat fan is kind of under ideal conditions when we want to get a product really to adhere to the leaf blade with great uniform coverage. And as we've seen in the industry, many are now using the air inductions because it gives us kind of the best of both. Depending on the output, we can place that product on the leaf blade, or we can get a little bit of it to run off into the root zone. So let me just wrap things up by turning off the sprayer and kind of summarize the day here. So I think we did a really good job at talking about the art of application. When we talked about nozzle, selection, we touched on output, we touched on pressure, and we touched on the design and how it can really impact the amount of droplet sizes that we have in terms of deposition on the leaf blade or on the plant. I want to thank you and the team at Honeywood for your time here today in the Applications Technology Lab. It's really been inspiring to kind of see what nozzles can do for the efficacy of our products. And I think applicators out there will really take this to heart when they make their next applications. Thanks a lot, Sheen.
Thanks for coming, Matt.